Look up tonight. Every gap between the stars should be blazing white, not black. Stack an infinite universe of infinite stars, and every line of sight should end on a burning sun. That's the first crack in physics, a mystery nobody has fully closed, and there are 6 more, each one worse. 6 cracks in reality, climbing from a dark sky to a paradox that could break physics itself. Let's go. First, astronomers call it Olbers Paradox. Why is the night sky dark, not blazing with starlight? In a universe old enough and big enough, stars should paper over every square inch of sky with light. Instead, most of the sky between stars is black, which by 18th century logic should not be possible at all. The fix wasn't more stars, it was time. The universe is only about 14 billion years old, too young for that light to arrive. And it's still expanding, stretching that ancient starlight into wavelengths our eyes can't even see. So the dark sky isn't empty, it's just hiding an unfathomable amount of light you'll never get to see. Space just tricked your eyes. Wait until it starts tricking your clock too. Second crack. Put your twin on a ship near light speed, and when they land, you've aged decades and they haven't. Relativity says both of you are right about your own clock, which means time itself isn't the same everywhere. Speed slows your clock, gravity slows it more. Neither twin is lying, they're just living through different amounts of time. This isn't theory. GPS satellites correct for this exact effect daily, or your map would drift off by miles. Somewhere right now, satellites are quietly outaging each other by fractions of a second just to keep your phone's map accurate. Time already bent for 2 people in one universe. So what happens when you look at something without touching it? Third crack. Quantum particles don't pick an answer until something looks. Until then, they exist as every possibility at once. Schrödinger sealed a cat in a box wired to a single radioactive atom that might decay at any random moment. If it decays, the cat dies. If it doesn't, the cat lives. Quantum math says until you check, both outcomes are equally real. That's not a metaphor in the equations. Mathematically, the cat is both alive and dead until the box opens. The cat is literally alive and dead at once. Schrödinger built it to mock that very idea. He wasn't proposing this as truth. Schrödinger designed the cat to show how absurd it sounds when quantum rules meet the real world. Decades later, physicists still argue about what looking even means at the quantum level, and nobody fully agrees. Reality won't pick an answer until you check. So what happens if you erase the question before it's asked? Fourth crack. Travel back in time and stop your own grandparents from ever meeting each other. If they never meet, you're never born, and if you're never born, you couldn't go back to stop them. The universe would have to erase its own cause, which is exactly the kind of contradiction physics refuses to allow. One proposed fix. The trip splits reality into a new timeline, and you simply erase a grandfather that was never yours. Another fix is blunter. The universe simply won't let the gun fire or the meeting fail, no matter how hard you try. No time machine exists yet, so technically no grandfather has been endangered yet. Both fixes patch the paradox by bending an even bigger rule. Cause always comes before effect. But quantum physics doesn't even need time travel to break connection across the universe. It does that instantly, right now. Fifth crack. Entangle 2 particles, fling them to opposite sides of the galaxy, and measuring one instantly changes the other. There's no cable, no signal, no delay. The second particle reacts before light could have crossed the distance between them. Einstein hated it. He called it spooky action at a distance and refused to believe nature could be that strange. For decades, it stayed a philosophical argument until physicists actually ran the experiment and entanglement won. No usable information moves faster than light. The connection is real, but you can't use it to send a message. Somehow the universe is more connected than causality should technically allow, and nobody has a clean explanation for why. A universe this connected, this vast, filled with billions of stars like ours, should be loud with life. It's silent. Sixth crack. The math says the galaxy should already be teeming with civilizations older and smarter than us. Billions of years, billions of habitable worlds, and the sky stays silent. No signals, no probes, no proof anyone else exists. Physicists call this the Great Silence, and it should be the loudest thing in the galaxy. Maybe civilizations wipe themselves out before they reach the stars. Maybe intelligence itself is the rare part, not life. Or maybe everyone's out there, listening just as quietly as we are, each one too scared to shout first. Every solution to Fermi's silence is a guess wearing a lab coat. The honest answer is nobody actually knows. That silence stings, but it doesn't threaten physics itself. It's a mystery about what's out there, not the rules underneath it. The next crack is different. This one doesn't just puzzle physicists. It threatens to break one of physics' two foundational theories. Final crack. Drop a book, a star, or yourself into a black hole, and relativity says every detail is gone forever. Quantum mechanics has the opposite law, one of its most sacred. Information can never truly be destroyed, period. Two of the most tested theories in history are staring at the same object and disagreeing completely. Pick one to save. Relativity's rule that nothing escapes, or quantum mechanics' rule that nothing is ever erased. They collide. This is Stephen Hawking's own problem. He showed black holes slowly leak radiation and eventually evaporate away. If the black hole eventually disappears completely, where did everything it ever swallowed actually go? If that information is simply gone, quantum mechanics is wrong. If it somehow escapes, general relativity is wrong. One of Einstein's two greatest theories has to give, and after 50 years, nobody has proven which. Some physicists think the information hides, smeared across the event horizon, encoded in a way we haven't learned to read. Others think space and time break down at the singularity, and our equations simply stop meaning anything. Nobody has solved it. Not one physicist, not one equation, in over 50 years of trying. This is the sharpest edge in physics. The one place our two best theories of reality actually contradict each other. 6 cracks in. Look back at them together, and something strange starts to show up in every single one. Every paradox on this list isn't nature breaking. It's two of our best mental models colliding at their edges. Olbers' sky broke an infinite universe assumption. The twins broke a shared clock. The cat broke observer from observe. The grandfather paradox broke naive cause and effect. Entanglement broke locality. Fermi broke our assumption we're not alone. And the black hole paradox breaks the biggest assumption, that relativity and quantum mechanics can both be true at once. Each paradox is a message. The model is incomplete here. Physics has been reading those messages for a century. So why does a dark sky matter when the real fight is happening at a black hole's edge? Because it's the same fight. Every one of these 6 paradoxes is the universe telling us where our maps stop matching the territory. The dark sky told us the universe has an age. The black hole paradox may be telling us it needs a deeper rulebook. Some physicists think solving it needs a new theory, one that finally merges gravity with quantum mechanics. Until then, the smartest people alive are stuck arguing about a hole that might be quietly erasing the universe's receipts. That's the strange comfort here. The universe isn't broken. Our understanding of it is still under construction. Every paradox you just watched is a live crack in human knowledge, waiting for someone to close it. You live inside a universe that is simultaneously ancient beyond imagining and still arguing with itself about its own rules. That's not a flaw in reality. That's the most exciting sentence a physicist can write. We don't fully know yet. Every paradox you just heard started as one person, refusing to accept that's just how it is. The next crack might be found by someone watching this exact video. If 6 paradoxes broke your brain a little, wait until you see what happens at absolute zero, where physics gets even weirder. Subscribe and we'll take you there next, into the coldest, strangest corner of physics we haven't cracked yet.